All right, guys, so what we're going over today is determinants, and we'll cover Cramer's rule tomorrow. So the main thing we're going over today is determinants. All right, guys, what we're looking at today is determinants. Really what we're looking at is determinants. Now, the first type of determinant that we're looking at is second-order determinants. Now, the two ways that we can see something written as a determinant is, well, DET, then we have our matrices in brackets. The other way that we can know that we're taking a determinant is instead of brackets, we have absolute value bars. So we have it written like this here. It is telling us that we're taking a determinant. Now, the determinant of a 2 by 2 matrix is just going to be taking the product of the diagonal going from right to or left to right and subtracting it from the diagonal going from right to left. So for this here, we're going to have AD minus BC. Okay. Well, let's just look at some examples, and this will make a little bit more sense. So when we look at this here, this first one here, A. Well, the first diagonal that we're going to have is and. So we'd have 5 times 9 minus, diagonal going the other direction would be negative 4 times 8. Any questions on this here so far? That was yesterday's. 4 5s over on the table. Now, 5 times sine is minus negative 4 times 8 would be, well, the negative and negative would make a, so 45 plus 32 is?
You do math at home?
Yep.
Like, just like, huh?
Yeah.
What?
Yeah, that's it.
It's not that hard. It's just cross.
See the circle.
So guys, these here, we can do them in the calculator, because most of the stuff that we can do in matrices, we can plug into the calculator. But really with these second degree determinants, why? Because for these here, really, I feel like you could probably do these here, solve these here 2 to 3 times over by the time you actually get it plugged into the graphing calculator and get it solved. So if we looked at the next one, well, we would do what? So 0 times negative 11, and then we would subtract from it. Well, 0 times 11 is? Well, 11 times 0 is? Yeah. Because we could say 0 minus 24, which will still give us negative 24. Look at 1A. Let's put here. So the first what? Negative 6 times 8 minus. Now at this point here, we could type this into the calculator and do just the multiplication out. Because we can say negative 6 times 8 is, negative 7 times 10 is, well, the negative and negative would make a, which is S. And that's it. That's all we have to do for this here. Yep. Yes. Next one, so this one here would be 7 times minus 5 times 9. Well, 7 times negative 4 is negative minus 45, which would give us negative 73. Any questions on this here? Yes. Now, these are the steps for taking the determinant of a 3 by 3. Now, I'm not going to go too deep into those steps. We're just going to go on and look at them. Now, when we look at this here, we're going to take the diagonals going from the left to the right first. Well, as it's written here, if we look at all those diagonals, well, this here would be 1. That there would be 1, and then this here would be 1, because it's going to wrap around. Now, trying to do that as it's written is going to be a little difficult. See. And then what we're going to do is we're going to write the first 2 columns next to it. So we're going to rewrite, so we rewrite the determinant and then write the first 2 again next to it. Yeah. All right, guys. So our diagonals is still going to hold true because we're going to have 1, 2, 3 diagonals going across. And the reason we wrote those first 2 columns again was to see those diagonals nice and clearly. So from the left to the right are going to be multiplied together. So we have 4 times 2 times 9. The next one would be negative 8 times 6 times negative 4. And the last one would be 3 negative 3 times 5. Because these are just our diagonals going from the left to the right. Now we're also going to have diagonals going from the left to the right, going in the other direction. But let's figure out these here first, and then we'll deal with the other diagonal. So we're going to multiply these numbers together. So 4 times 2 times 9 would be 72, because 4 times 2 is 8 times 9 is 72. The next one we would have is 8 times negative 4, which would give us 192. And lastly, we would have 3 times negative 3 times 5, which is negative 45. Now, unlike the first one, what we're going to do is we're going to take all 3 of these numbers and just add them together. We're going to add all these numbers together. And if we add them all together, we get 219. So the number we have from all the diagonals going from the left to the right, multiplied and added together is 219. Okay. Any questions on this so far before we move on to the next part? Now we're going to take the diagonals, go in the other way. So we would have negative 8 times negative 3 times 9. That's just our first diagonal. The next one would be 4 times 6 times 5. And the last 3 times 2 times negative 4, because now we're just taking the diagonals going in the other direction. And then we'll just multiply these together. So we'd take 8 times negative 3 times 9, which would give us positive 216. 4 times 6 times 5, it should be 120, because those should all three be positive. And 3 times 2 times negative 4, negative 24. And at this point, we would add all three of these together. This 300 something. Let's see here. 312, I think. Yeah. That was very close. Any questions on this here? Now we just subtract the 2. So once we get the diagonals going from left to right and right to left, we subtract them. The ones going from left to right is going to be subtracted from the ones going from right to left. So we're going to take 219 and minus 312. And if we subtract these, we get negative. And that's it. That's all we have to do for these here. Now for the 3x3s, it's going to be probably a little bit easier and a little bit quicker if we typed them in. If we typed them into the graphing calculator. Awesome. Yep. So if we're going to type this into the graphing calculator, the first thing we're going to do is input the matrix in. Well, the way that we input the matrix in is going to be second matrix. And we're going to go over to edit. So we want it to be a 3 by. And then I want to type the matrix in. It should be negative 5, 9, 4, negative 2, negative 1, 5, negative 4, 6, and 2. Because once we get this plugged in, we can do what? Second quit. At this point here, we're going to go second matrix. And this time we're going to go over to math. We want to determinant. Well, determinant is going to be our DET, which is the first one on the list. So if we hit enter, we get this here. Now we can't hit enter again because we haven't told it what to take the determinant of. What we can do is go second matrix, enter to recall A, and then enter one more time. So the determinant of 2A is negative 48. And that's it. Any questions on any of this here? This here is negative. What is about